Hello everyone, welcome back to the channel. Today's video is about shaders introduction, so if you're already familiar with shaders, well then, it's pleasure talking to you. You can safely skip this video. Okay, for this video, I will be using Godot version 4.1, and with that out of the way, time to roll the intro. Okay, before we dive into the topic, let me clarify something first. Just because I have put Godot in the title does not mean that whatever I will talk about will only apply to Godot. Remember, shaders are basically maths, and mathematics is universal. It does not have any platform boundaries, so it can be used in Godot, Unity, Unreal, Blender, basically every 2D or 3D platform. Okay, now what are shaders? Shaders are programs that runs on the GPU that determines how it will render or output any 2D or 3D objects on your screen. In Godot, there are 5 types of shaders: spatial, canvas item, particle, sky, and fog. Spatial shaders are used to render 3D objects. Canvas item shaders are used for any 2D objects including UI. Particle shaders are used to render particles. Sky shaders are used to render skybox, and hence it is my favorite type. Finally, fog shaders are used to render volumetric fog. In each shader types, there will be processor functions. In Godot, there are these processors, but we will going to talk about the 2 most common ones which will be present in almost all game engines: Vertex processor and Fragment processor. What is a Vertex processor? In Unity, it's called Vertex context, and it is basically a function or method which gets called for each vertex of our mesh. And Vertex processor is basically used to determine how our mesh's geometry will be rendered. What is Fragment processor? In Unity, it is called Fragment context, and it is basically a function or method which gets called for each fragment, or simply put, each pixels of our rendered mesh. And it is basically used to determine surface properties of our mesh like albedo, metallic, roughness, etc. In Godot, there are 2 ways to create our own custom shaders. First, by writing the shader code, and second, by using Visual Shader Editor, which is a node-based interface very similar to Unity's shader graph. We will going to create a simple flag shader which will deform as if it is waving in the wind using both methods. I have this flag node in our scene which has a mesh instance 3D for our pole and flag. The flag mesh has some extra geometry, so we can deform it, and I have created it in a way so that it matches the aspect ratio of the texture which we will apply on it, so that we don't have to worry about matching the aspect ratio for now. First, let's write our own shader, and for that, right click, create new, resource, then we will search for shader in the list and hit create. We will keep the mode spatial because our mesh is 3D. Then we have template, and the default one will provide us with our fragment processor. I will give a proper name to our shader. We call it flag. Now we have our shader, but in most game engines, almost in all of them, we cannot directly apply our shader to the mesh. We need to create a material for that. So again, right click, create new, resource, then in the list, select shader material. I will call it flag, and then select .material extension and hit save. Double click our newly created material. It will open up in the inspector dock, and here it has a shader property. Let's assign our flag shader to it. Then I will assign our material to our flag mesh. So the material will tell Godot how to render our flag mesh, and material is the asset or resource that holds the actual shader code. Okay, let's double click our flag shader and it will open up in the shader editor window. Here we have defined type of shader and we want to modify the look of our mesh, so we will use fragment processor. It will be called for every pixel of our flag. Now Godot uses a purpose-built shading language which is based on GLSL, aka OpenGL shading language, and it has similar syntax like C language. So Godot's shading language is strictly typed, so you must define the type of your variable and it won't implicitly cast one data type to another. You have to explicitly cast it, meaning float values will not automatically be cast into integer or vice versa. So I cannot do int my int equals 1.0 because 1.0 is a float, so I have to explicitly cast it to int. Also it is I forgot the actual term, but it is not a free-form language, meaning functions must be defined before we can call them. So I cannot call my function because compiler doesn't know at this point what is do something. I need to define the function before the function call. Okay, now notice that our flag is only rendered from this side. Most game engines will render the geometry this way to save the performance, but here we need to render the other side of our flag. For that, we will set the render mode to cull disabled to render the back face as well. Now we want to apply the texture, so let's define a sampler 2D. I will call it main texture. And we want to apply our texture from the inspector, and for that we will use uniform keyword. Then in our fragment processor, we want to apply that image, so we want to assign it to albedo, which is the built-in variable, but we cannot just assign our main texture to it because it just holds our texture resource. First we need to sample it in the actual texture data type, so we will use texture function. Then we need to pass what I want to sample, so main texture. And the second argument is on which coordinates we want to sample it or how we want to sample it. We will sample it using the actual UVs of our mesh. Now texture function will return vector 4 because it has red, green, blue and alpha channels, but our albedo accepts vector 3. So we need to cast it, or we can just assign RGB channel like this. We can also use XYZ. It is basically the same thing. Now our shader material will have a slot for our main texture. I will assign this texture. Now we want to make our flag wave, and for that we have to modify vertices of our mesh. And to modify the vertices, we need Vertex processor. Here let me define a vector 3, position, and I will assign the original vertex position using Vertex, which is the built-in variable that will provide each vertex position in local space. Now Vertex processor will run for each vertex of our mesh. So for this vertex, let's assume we will get 0, 0, 0. Then for this vertex, we will get 0.100. For this vertex, it will be 0.200 and so on. Let's modify the Z value of our position and then apply the modified position to our vertex. And you will notice that our flag moved slightly in the Z-axis. Now we are adding 0.3 on Z for every vertex. We need to add different values for each vertex to make it wave. Now for the vertices at top, we have same Y and Z value, but the X will be different. So we will use X value with sine function. Sine function will return values between -1 and 1. And now you can see our flag deforms like this. Now we want to deform it over time, so I will just add time. Time will give us the time in seconds. And now our flag will start to wave. And I want to control the speed of the waves and strength of the waves in z-axis. And we want to control them from the inspector, so let's define two uniforms. Then multiply our time with wave frequency and multiply the whole equation with wave amplitude. And now we can control the wave speed and strength from the inspector. However, it looks like our flag is moving in the opposite direction of the wind, so I will just negate the time like this. Now it looks good, but it is not attached to our pole. To fix that, we will use our UVs. UVs will have value of 0, 0 here and 1, 1 here. We will use X value of our UV. So let's multiply our entire equation with uv.x. So basically for this vertex, our uv of x will be 0. So whatever this equation will yield will be multiplied with 0. So no movement. And here the value of x will be 1. So full movement on z-axis. And we have our waving flag. Pretty cool. Alright, now let's do the same thing with Visual Shader. So right click, create new resource, then search for Visual Shader and hit create. Keep the mode to spatial. I will call it Flag Visual Shader. Now I will use the same material, so I will just drag our Visual Shader and assign it to our material. Now again, we want to render both faces of our mesh, so select our Visual Shader. In the inspector, go to Modes and set Cull to Disabled. And now both our faces will be rendered. Then we will go to Fragment Processor and we can change the processor from this drop down. Here we want to apply our texture from the inspector, so let's create a texture to the parameter node. Let's call it main texture. And we will see this parameter in the inspector. Keep in mind though that it will only appear after you use it in the master node. Then again, we have the same problem that I cannot feed the output to our albedo. We need to sample it, so we will create texture 2D node. Then make sure that we have selected sampler port. Then take our main texture and feed it into the sampler 2D. Then take its output and feed it into the albedo. And we will be able to assign the texture from the inspector. Now let's deform our mesh, and for that let's go to Vertex Processor. Then we will create a Vertex node. Well, actually it is input node, and we can access various built-in variables. Take its output and feed it into vector3 decompose node. It will split our vector into x, y, and z. Now I'm going to follow the same logic from our flag shader. So first let's create two float parameter for our wave frequency and wave amplitude. We can set the default values by checking this default value enabled and then set the default value. Now we will multiply our wave frequency with time. Make sure you have selected float operation for multiply. Then we will subtract our vertex positions x with this multiply. Then take subtract node's output and feed it into sine node. Then we will multiply our sine values with our wave amplitude. Now we want this new value to use as z, so let's compose or create a vector 3, and for that we need vector 3 compose node. It basically combines x, y and z and give us vector 3. Take our multiply node's output and feed it into z. We will use same x and y. Then take our vector 3 compose node's output and feed it into the vertex slot. Now we have the same problem as before. So let's create a UV node. We want x value of our UVs, so take its output and feed it into vector 2 decompose node. Then we will take its x and multiply it with our equation. And finally take its output and feed it into the z. And now we have the same effect using visual shader. Yay! Now you can use either of the two methods to create your custom shaders. However, I will encourage you to learn shading language a bit, because right now I find visual shader a bit restrictive. For example, we don't have twirl UV node or rotate UV node. We can of course write our custom logic using expression and global expression node, but to write that we at least need to have basic knowledge of shading language. So yeah, it is a bit counterintuitive in that sense. We can use custom add-ons to overcome that, and yours truly is also working hard to get those missing nodes in the core engine itself. But it will take time. Okay, so now you have basic idea of shaders, and I think now you will be ready to dive into the documentation without finding it overwhelming. That's pretty much the video. If you find the video helpful, consider like, share and subscribe. Wishlist my game Cosmic Roads on Steam. If you have any questions, post them in the comments. That's it from me, and I will see you guys in the next one.